So multiple choice, the first question. So it's asking for a maximal domain. So we have to look for in one of these functions, like an issue, I guess. So you can check the first function, which is a parabola, but we know parabolas have a domain of all real numbers, so it's not going to be this one. And we know the log function is only from 0 to infinity. 0 to infinity, so you know this is going to be the maximum domain because it's going to be the smallest domain of the two. So it's going to be B. So circular function, so amplitude, period, and range. So amplitude is going to be the distance from the middle up and down. So in this case, it's going to be 3. So you can get rid of C and D. And then range, you can easily see is from 4 to -2. So you can not, you can't really get rid of any of the answers. But the period, you know, it's going to be 4. So it's going to be E. So, yeah. So question 3, if x plus a is a factor, then that means that p of a is 0. So all you have to do is put -a into here and then equate it to 0 in your cas, and you should get D. So this is asking for asymptotes, and you can see you kind of have a weird function here. But the way to do this question is to realize that it's a truncus. A hyperbola, and then you have to get it into hyperbola form. So you have to like transform the equation. So you start with the denominator, and then you start to make the numerator. So if we expand this, we would get 2x plus 8, and we originally want 2x minus 3, so we have to minus 11 from here. And then you can split it into proper fractions. And then you can easily see that these two are going to contribute to your asymptotes. So one asymptote is going to be y equals 2, and the other one's going to be x equals -4, which is A. So if this is a discrete random variable, then this whole bottom row is going to be equal to 1. So if you look at the answers, you'll see that none of them have B in them, which means you actually have to find what B is. So that's why we need this. So if you add the bottom rows, you get B equals 1. And then to find EX, you would do -B. So this multiplied by this one added to the rest of them. So -B plus 0 plus B plus 6, 5 minus 2B plus 9B on 5. And just sub whatever value you get for B from here. And you should get A. So for question 6, it's just a cas thing. So let define fx in your cas and then do f of fx equals this value. And then you should get the answer C. But the thing is that the domain is restricted from 0 to infinity. So you can't actually accept the negative. Oh, sorry, you would get this answer, but you can't actually accept the negative because it's not within the domain. So the answer is D because you can only take the positive answer. So for this one, you can just solve this right-hand side on the cas and then just put the answer to that in Euler's number. So like, so solve for this in your cas, you get like alpha, that's the value you get, and then just put that as this, and you should get 9. So simultaneous equations, so if they have infinitely many solutions, that means they're the same line. So if we rewrite this in a way we can understand it on 2, and the other one is y equals k minus 3x on m. So if they're infinitely many solutions, then gradients have to be equal. And the y-intercept, so the c value, also has to be equal. So if we start with the gradient, negative m minus 1 on 2 equals -3m. So m squared minus m equals 6. M squared minus m minus 6 equals 0. So m minus 3 is m plus 2. So m is either 3 or m is -2. And usually one of these answers will not work. So you always check with the y-intercept. So the other thing that has to be equal is 2 on 2 equals k on m. So since we have like two variables here, we're just going to want to have k in terms of m. So you can see that when k and m are the same value, then there's going to be infinitely many solutions, and m can only be one of these two. So basically, for there to be infinitely many solutions, k equals -2 and m equals -2, or k equals 3 and m equals 3. So the only answer that's one of these is D. So probability question. So she has 3 red apples and 2 green apples to start with, and she eats one every day. So we're talking about 3 days, and probably that she doesn't eat an apple of the same color on any 2 consecutive days is. So to help visualize, you would draw a tree diagram. So she could eat 3 reds or 3 greens. She could eat green here, red here, red, green. This is getting a bit squish, but yeah. So, and the other thing to be careful is that she obviously does not replace them. So, because she just eats them. And also that there's only 2 green apples. So the possibility of getting 3 green apples is 0. Sorry, it should be out of 3. And you can just fill in your tree diagram like this. So probably if she's eating 2 on any 2 consecutive days, so that includes this line, this line, this line, this line, and this line. So anytime you see the same color on any 2 days, that line's taken. So you can see that pretty much all of them except for this one and this one are taken. So instead of calculating everything, you're just going to do 1 minus the probability of these 2, and you should get C. So probability density function is this. So the value of k. So if it's probability density function, then we know the integration of it from its domain is going to be equal to 1. So you just do that for this and solve for k, and you should get C. So this function is going to have an inverse function. We know that it's going to have to be 1-to-1. So to do that, we would graph it first. And I think from what I remember, it looks something like this. So then you just check each answer. And we're looking for the domain for which it's 1-to-1. So all real numbers, no, it's not 1-to-1 because it has like a local minima and maxima. I think this was 0 and this might have been -3, I'm not sure, but so we check the next answer. So -2 to infinity again does work because we have a local minima at that in that domain. Infinity to half, so again that won't work because that's including both of these. Negative infinity to 1, -1, so it's up to here. Still won't work because it's including this local maxima. And then 0 to infinity, and then you can see that does work because it doesn't include any of the stationary points. So the answer is E. So now we're looking for a matrix. So to do this, instead of trial and error, what you want to do is work backwards. So if this is our transformed function, and this is our original function, so this should be written in terms of y dash and x dash. And then we can rearrange this so it looks like the transform function, and then you can just equate things. So y dash is equal to y plus 3 on -1, and x dash is equal to 2x plus 1. So when you look at matrices, right away when you expand them, it's in y dash equals something and x dash equals something. So we can use these forms exactly as they are here. You just might want to expand them because like you can't get -1 of y plus 3, because as you can see, there's no brackets in any of them. So if we're going to get a -3, it's going to be because they're taking away 3, not because they're multiplying it by -1. So first thing we look at is 2x plus 1. So this is half, this is half, half. So we're left with these two. And then the y is -y minus 3, which is d is the only one that works. So now we want exactly 2 stationary points. So if we're going to find stationary points, we're going to let f dash x equal 0. So f dash x here is 3x squared minus 12b minus 2x plus 18. So if we want 2 stationary points, then there has to be 2 solutions to this. And conveniently for us, it's in a quadratic form. So we know if we want 2 solutions in a quadratic, the discriminant has to be greater than 0. So you could just solve for that on your CAS. And if you realize this and somehow you make a mistake on your CAS, you can already get rid of some answers because you know the discriminant is going to be greater than something. So the answer is going to be b is greater than or less than something. So it can't have any equal signs. So you can get rid of b, c, and d just with that information. Because as I said, the inequality is going to be greater than, not equal to, or anything like that. So you can just easily get rid of all 3 answers. So question 14. So if we want x in terms of y, we have to rearrange everything. So we can absorb the 2 into here. And then since it's going to be x minus of the other log, you can divide. 2 equals y. And then since they're both logs of the same base, you can just equate them to each other. So x squared is yx plus 2. And then you can see it's going to be a bit of a problem because we have multiple things. But if you expand it and just use quadratic formula, or you can even do this on your CAS will do it for you. The answer should be A. You'll get, sorry, you'll get y equals plus or minus. Like this one would be plus or minus. But it can't take the minus option because if you look here, log y, so that means that y has to be greater than 0. But if you do y minus square root y squared plus 8y, this will be less than 0, so you can't accept this answer. I mean the negative part, so that's why you only take the positive part. So we have the area between this given, but what we actually want is the area, this one. So to do this one, we're gonna use this like little trick. So 10 to 4, 3f(x minus 2). So if we want the same thing here and here. So if we're gonna use dx minus 2, then we have to multiply this. Okay, we can't really do anything because there's nothing wrong with it. There's no dilations, so we can leave this as 1. But we do have to change the boundaries. So if it's x, it's 10. So if it's x minus 2, then it's 8. And for the bottom one, if it's x, it's 4. So if it's x minus 2, it's 2. And then conveniently, we actually have the right domain as the area given. So the area here is 3 ln 13. In the same domain, so this is fx dx from 8 to 4. So now we actually have this in the middle, and we can ignore the x minus 2 because if these two are the same, then basically it applies to any time where they're the same because it's just a variable. So now we have 3 integration 8 to 2 fx minus 2 dx minus 2. So we know this area, so we can just do 3 times 3 ln 13. So it's 9 ln 13. So the answer is B. So g of f of x So there's composite functions. So this is testing your ability to recognize the domain and range of each function and then which corresponds to which. So if it's g of fx, then we know the range of fx is going to be a subset of the domain of gx. And also that the range of fx will determine what the range of gx is. So in this case, so fx is kind of the most important part. So you can see for fx, the range of fx is from here to here. And like, so for x, say I'll call this x1. So for x1 to infinity, you have the same values as x1 to negative infinity. So whatever gx is, it's gonna be at x1 for gx, the right hand side and the left hand side where the axis of symmetry is at x1 is going to be the same. So that's based on the fact that the range of fx is the same for those values. So you can easily get rid of quite a few graphs. So you can get rid of A and B. And you can see the rest of them are they have a bit of symmetry here. So they're fine. And the next thing you look at is what actually is the graphs, like what are they doing? So you can see that gx is like a hyperbola, and you can see it's a negative hyperbola, sorry. And you can see the range of fx, I guess, is from like, maybe this is alpha, where alpha is like greater than 0. So if you consider a negative hyperbola and you take a number greater than 0, oh, sorry, this is a positive one. So a negative hyperbola and you consider a number greater than 1, then you can only consider the right-hand side because, again, the range of this is from alpha to infinity. That's a square bracket, sorry. So alpha to infinity, so it's going to be the same here, same here. So the graph of this side is going to be the same as the graph of this side. So you can see whatever graph we're looking for is going to be underneath the x-axis. So we can get rid of D and C, so the answer is going to be E. So now we have a bit of transformations again. So to do this, you just need to work slowly to figure out what all the transformations are. So dilation by factor from 4 and pi from the y-axis, so that's going to affect the x-axis. And then if it's 4 on 3 from the x-axis, then it's going to affect the y values. A reflection in the y-axis, so that means it's going to affect the x values, y, and translation of 3 on 2 in positive y direction, so it's going to affect y values. So now we have x dash is negative 4 and pi x, so x is pi on negative 4 x dash, and we have, oh sorry, actually we don't need to rearrange it because we're not trying to find the whole equation, we're just trying to find some transformed points. So the range of period of G respectively are, so the period was originally 2 pi, and the range was originally negative 3 on 8 plus 1, so 5 on 8, and negative 3 on 8 minus 1, so negative 11 on 8. So first we can check the period. So x dash is negative 4 pi times 2 pi. So x dash is negative 8, but we don't have negative periods, so the period's just 8. So we can get rid of A, C, and E because the period has to be 8. And the next thing we check is the range, sorry. So you can see that both of these have different values. So all you have to do is sub one of these in. You don't have to sub both because one of these will not have the answer. So I think 5 on 8 is the easier option. So y dash is 4 on 3 times 5 on 8 plus 3 on 2. So y is 5 on 6 plus, so say 9 on 6. So it's 14 on 6. So it's 7 on 3. And the only option with 7 on 3 is B. So the area of the the shaded region is just the area of fx from point B to point A. So we can safely assume point A is 0, dx minus this triangle. So the first thing they have to do is find what point B is. So to find what point B is, just let f dash x equals 0 because that's the x-intercept. And then you can do beta 0 fx dx minus half base times height. So b value times a value, and that's your answer, and you should get B. If you ever can't find it in the same form as these, just put your cas to decimals and just test your answer with each of them. It's a bit slower, but if you don't think you can find it in the same form, it's like a guaranteed answer. So we have sampling now. So you can tell it's sampling through the word proportion. So we have a 95% confidence interval and the number of computers used. So again, we know the confidence interval is made by this. Oops. And P1 minus P on N, and then P hat plus 1.96 times P1 minus P on N. So we have two unknowns right now. We have P and N, but as I said before, so P value can always be found by getting the average of these 2 points. 147 equals P. And then all you have to do is, using this P value, just equate either the top one to 0.8147 or the bottom one to 0.6668 and just solve for N. And you should get 135. I think you actually get a decimal, but it's asking for the closest to, so you would assume a whole number. So question 20, so G is the inverse of F. F is this. Given that F is 0 is 1, what's the value of G inverse 1? Inverse dash 1. So we'll start by finding what G inverse is. So G inverse is, so we have to swap, so let Fy equals X. You don't have to do this working out when you do it, because that would be a waste of time, but just because I'm explaining it, I guess. So X plus B, so X is Y 1/5 minus B on A. So, sorry. So G inverse X is 1 on A, Y to the, X to the 1/5 minus B. Yeah, so we have you can see there's going to be a problem here because all of the answers don't have B in them, but you can see if you differentiate this and put something in here, it's going to have a B in it. So then we have to use the information to get rid of B, and the information we're going to need is this one. So F0 equals 1. So that means A times 0 plus B 5 equals 1. So B to the 5 equals 1. So the only answer B could be is 1. So now we can sub B into here. So 1 on A, X to the 1/5 minus 1. 1 on A. So I'll just expand it. So minus B on A. Minus 1 on A. So now we can differentiate it. So G inverse dash X. So 1 on A times 1/5 1/5 times 1 on X to the 4/5 And then this is a constant, so it's just plus 0. So it's 1 on 5a x to the 4/5. And then you sub 1, so 1 on a 5a times 1 to the 4/5, but 1 to the power of anything is just 1. So it's just 1 on 5a, which is c. So that is multiple choice. So short answer. So we have two graphs here. This one is power 5 graph, and this one's a power 6 graph. So that's important to note. Just so you can see this is a odd function and this is an even function. Because it's symmetrical. So this, you can clearly identify that this is the x to the 6 graph. And this is x to the 5 graph. So find the values of c and d. So all you have to do to find c and d is, because it's the other point of intersection, so just let fx equal gx, and you get the x value. So the x value is c, so c is 2. And then to find d, you can just put it into g or f, doesn't matter, because they're both intersecting at the same point. And you should get 64. So find values of x so that fx greater than gx. So you could just put this into your CAS and literally do fx greater than gx. And you should get x as an element of negative infinity to negative 2 intersection 2 to infinity. And just always make sure to check your answer using the graph. So you can see negative infinity to negative 2 is here. And then the sum point here to here, which makes sense because for the in-between part, the dotted graph is on top, which is not what we want because that's gx. So again, for these two, just put it into your CAS and make sure you check your answer with the graph that's given. And so for this question, if you ever like confused as to why the 1 is there, so you would look at where 1 is, and so 1 is a stationary point. So you know it can't be less than 0 because at 1 it's going to be equal to 0. So that's why there's an exception at 1. So this one is going to be negative infinity to negative 2 intersection, negative 2 to negative 1/5, and intersection 1 to infinity. So yeah, just checking your answers. So now we have to show that question. So f of 1 plus m is maybe all right. Left hand side is this. So 1 minus. So just because it's a show that question, just show that you subbed it in properly before you simplify. So m to the 3 and plus 3 to the 2. You don't have to expand this because you'll see when you do the other side that you actually get to the same step. But since you probably wouldn't know that beforehand, you could expand it. So 9 and 5 plus 27 and 4. Yeah, so don't expand it by hand, just put it into CAS. And then, so the right hand side is f of negative 2 minus m. So negative 2 minus m minus 1, 3. And then negative 2 plus 2 minus m, 3. So negative 3 minus m, 3, and then m3. Sorry, this is a negative m3. So you can see that you have two, like, so this one you can also take the negative out of, and you can also take the negative out of this one, but you have to be careful because it's the power of something. In this case, it doesn't really matter because it's to the, like, it's negative 1 that you're taking out. But in another case, it may have been important. So negative 1 to the power of 3 is negative 1 from here. And same with here. So if you multiply these two, you just get positive. So that's why it's going to be 3 plus m to the 3, m to the 3. So you actually get the same answer here. But you might want to expand it, but it doesn't really matter. Just make sure you write equals left-hand side and equals right-hand side on both of them. So find values of h for gx plus h as one negative solution. So it's asking for a translation to the left for which there's only one x-intercept that's negative. So if we look at the graph of gx, so oh, this is a mess. So gx is the dotted graph here, this one. So we're going to have to move it to the left and to the right so that it only has one x-intercept. So we know only this one can be the negative one, because if we're going to make this negative, we're going to move the whole graph to here, but then both of these will be negative and we only want one. So the one that's like, I guess, designated one is this one. So all we have to do is make sure this stays within negative infinity to 0. So to do that, we can move it 2 to the right, or we can move it an infinite amount. Oh, sorry. Where is gx? 2 to the right or 1 to the left. Gx plus 1. I have suddenly forgotten why I cannot move it. Oh, right. So you can't, so for this point, you can move it 2 to the right and an infinite amount to the left. But the thing is, we can't actually move it an infinite amount to the left, because then this point will start to come past this, past the y-axis, and this will become negative as well. So moving it to the right doesn't matter because this only gets more positive. But moving it to the left, we can only move it a maximum of 1 to the left. So our total transformation, I guess, is 1 to the left and 2 to the right. But these h. So h is, because it's plus h, then it's transformation to the left. So before we said 2 to the right and 1 to the left and 2 to the right, considering like plus is positive to the right, but in this case plus is positive to the left. So we swap the negatives and h is an element of -2 to 1. The one is inclusive, because if you move it 1, then this point's going to be 0, so it's still not going to be negative. So we can include the 1, the end value of 1. So, so to find values of this that has no solution, so the easiest way to think about it is just to equate it to -k. And then think about it like you have a graph here, and you're just moving a line of y equals k, -k, up and down, and you're just testing for which values you only have one solution. So you can see if you move it past this maximum here, you're only going to get one value, and if you move it lower than this maximum here, you're also only going to get one value, and then you just apply that to the graph of this graph, so gx, or no, sorry, this is fx. We want no solutions. So for no solutions, we're going to see if any higher value, we're always going to get us to at least 2 solutions, because it's going to be like this forever. If we go all the way here, it's going to be 1 solution. But you can see if we go any lower than this, the graph ends here. So there's going to be no solutions. So what we want is the k values from here to here. So we want k values. So we want y as an element of the local minima, which you should find in your CAS, 64 to -infinity. But we're equating it to -k. So we're going to have to swap the negatives around. So that means k is an element, so like -k. So y in this case is -k, because that's what we're equating into. So then k is an element of 729 and 64 to infinity. So question 2, so what's the amplitude and period? It's pretty simple. So amplitude is 16 and period is 2 pi divided by pi times 14, which is 28. Minimum and maxima, also easy. They're just testing the range of the function. So max is 36. B60, you could just sub in on your cas and you should get 32.5093. Make sure you put units. And average value again is also cas. So this whole page is pretty much, you shouldn't lose any marks because it's just cas. 60 to 0, and then VT dt, and you should get 20.45 kilometers an hour. So suddenly they're changing, so it's a new function. So they're changing the old one, and there's this k that we don't know what it is. And so this is after, so the change occurs at 10 o'clock. So up until this point, here it's the other graph, but as soon as you see this like weird bend here, it's the new graph. So find smallest value of k, show that v and t are equal and both increasing at 10 a.m. So there's two things to consider here, is that v and t are equal and they're both increasing. So the first thing you can do is equate v and t, and you'll get, make sure you restrict the domain from like 30 to 90, because otherwise you get like a lot of values. Maybe even like 45 to 75 is preferable. So 30 to 90, or anyways, like a value. Oh, sorry, this is k, my bad. So that's not what you do. Don't do that. So so it's going to be equal at v60. So you would let v of 60 equal v1 of 60. So then essentially, because you're subbing in 60, you get this as a function of k. So v1 of 60 is like 2818 sine pi on 760 minus k. So like this is now a function of k. And the other one, we don't really have a k value, so it's just going to be a constant, which makes it easier to solve for. But yeah, so solve this in your cas. Don't give k a large domain because we're looking for the smallest value of k. So you can make like k an element of say 0 to 20 or something, because we also have to check that they're both increasing. But in this case, the first answer you get is actually the right one. So you get a couple answers. I got 4358, 11.5642, and like 17.4379. So smallest value would be this one. So you would start from here and just make sure you check that once you put it into v1 dash at 60, so sub 60 and then sub the k value, that make sure it's greater than 0. So coincidentally, the smallest one is actually works for increasing. So the answer is the smallest one. But if it weren't, you would have to go to this one, check if it's increasing, and then go to the next one, check if it's increasing. So if it's increasing, then so if increasing means that b dash at 60 with that value of k is greater than 0. So just check that and find smallest, which for both the conditions are true. So now they're giving us the k value. So they're saying it's this one. And we need to find when the wind speed is greater than this. So with a question like this, just be careful that the thing they gave you in the right units is in the right units. In this case, it's fine, but just be careful. So find the value of when the signal is first sent. So just let v 1t equal 38 and sub this k value. And again, like restrict your domain a bit, because otherwise you get like infinite values. In this case, you might want to start from 10 o'clock. So that's 60 because we're in minutes. And so if we start from 60 and we're looking for 38, so it's going to be somewhere like here. So you might even just put 75. So 75. So that's just to restrict your domain. Otherwise, your CAS will give you a general solution and you can't really do much with it. But you get T is like 60.75 minutes. So find the proportion to the nearest whole percentage for which V is greater than this. So if we take one cycle, so say it starts from here and ends from here, and V is 38 is like here. So we're just trying to find the time between here over the whole time. So the whole time is the period, which we know we said before was 28. So to find the time for which it's greater than 38, just do the same thing here, except you're going to want to find the second solution as well. And if you do that, the second solution will be like 65.1233. So proportion of time spent over 38 is the difference between these two values. So minus 60.75 over the period, which is 14 times 100. So period 100. So, sorry, the period's 28. Period is 28 times 100, and you should get 31%. So there's another transformation, and we're mapping the graph of f onto the graph of g. So we have our original function and our transform function. So there's multiple ways to start this question. You could work backwards from here, or you could work forwards with the matrix. I like to work forwards with the matrix. So I'll start with expanding the matrix. So x plus c. So x is x minus c on A, and y dash is by plus d. So y is y dash minus d on B. So now you take sub 1 and 2 into fx. So y dash minus d on B is 20 plus 16 sine pi and 14 x dash minus c on A. And then just expand in a way that's comfortable. So 20b plus 16b, 16 minus 6 and b looks the same, 16b, pi on 4a x dash minus c plus d. So now you can just compare it to your gx. So I'm going to write gx in terms of y dash x dash because it's the transform function. So pi on 7 x dash minus k, x dash minus k, and yeah, that's it. So through comparison, so we'll start with b. So start with oh no. So we can, there's the c values and there's also this value. I guess we'll start with this value because like the other one we have to include d. So 16b is equal to 18. So b is 18 on 16. So b is 9 on 8. So now we have our b value. And what we want is the other two. So we have 20b plus d, but we also have x minus c and pi on 7. So let me just check if I'm doing this correctly. So it's basically we're just doing comparison right now. So 20 plus D is 20. Oh, I forgot the B. So 20B plus D is 28. So D is 28 minus 20 times 9 on 8. So D is 28 minus 10, 4, 5, 2, 45 on 2. 45 on 2 is a big number. So 56 minus 45 on 2. So that's going to come out to 11 on 2, which I'm pretty sure is right. Yep, so D is 11 on 2. And then the other problem that we have to deal with is A. So A is, we don't have to worry about C because you can see C and K are the same. But A is actually a half. So let me figure out why A is a half. Because something has gone wrong. Because if you see, you can see that if you do pi on 4A and you equate it to pi on 7, then you're going to get 7 equals 4A. A equals 4 on 7, which is not true. So I must have done something wrong. If anyone wants to jump in and help me, that would be great. Otherwise, I will stare and figure it out. Is it? Oh, I think I did this wrong as well. This is 7 on 4. 7 on 4. So this is 1/2 y x plus c x dash minus c on a. Slot that in. So, that's why. So this is 14. Sorry, my bad. So 14, 14, 14. So 7 and 14. So that's why it's half. There we go. So question 3 is probability. So we have Matt's land, concert hall. It's a random variable that's normally distributed. And we have our mean and standard deviation that's given to us. That's all. So proportion of concerts that begin before the scheduled starting time. So don't get tricked with the word proportion. We're not doing sampling yet. It's just asking what's the probability that L is, that's not, so sorry. So what's the probability that L is, so if starting before the scheduled time, then it's going to be L is less than 0 because 0 is the minutes after. So if it's going to be before scheduled starting time, then L is going to be like negative. So it's going to be less than 0. So just solve for that. And you get 0.060062. So find probability that concert begins more than 15 minutes after scheduled time. So probability that L is greater than 15 in this case is 0.1056. So now we have to use our answers from part A and B to complete the following table. So from reading this information here, if the person's going to get paid $0, then the concert's going to begin before, begins before or at the scheduled meeting time, so there's no extra payment. So you figured out the probability of it starting on time is this. But we only want this to 3 decimal places, so we're just going to use 0.006. And if they're going to get $200, then it's going to begin up to 15 minutes, more than 15 minutes after the scheduled starting time, which we figured in part B. So again, rounding to 2 decimal places, we get 0.106. And if it begins up to 15 minutes after scheduling time, so this probability is 0 to 15, and it's 0.888, or you could just do 1 minus these two because the whole thing has to add up to 1. So calculate the expected payment. So expected payment is going to be 0 times 0.006 plus 100 times 0.888 plus 200 times 0.106, and that comes out to $110 to the nearest dollar. So calculate the standard deviation. So standard deviation of C is going to be the squared expected value minus the expected value squared and square root of the whole thing. So just do it as you normally would, and you should get $32 to the nearest dollar. So it's asking us for a 93% confidence interval for the proportion of concerts that begin 15 minutes after scheduled time. So in this case, they're telling us that there's 1,000 concerts. So our n value is 1,000 because that's how many they've taken in the sample. And the sample value is 43. So that means 43 out of 1,000 concerts start more than 15 minutes after scheduled time. So the proportion of concerts is 43 on 1,000, and n, or the number of concerts, is 1,000. So you can just find your, using statistics, I think it's one sample C value interval, and you just find your confidence interval, or you could do it by hand, either way. 0.056. So explain why this confidence interval suggests that the proportion of concerts at Maxima concert hall is different from the proportional values in sample. So what the 95 confidence interval actually is that basically it's saying that you can be 95% confidence, sorry, you can be confident that 95%, wait, it's either one, but I'm just going to say it's going to be your 95% confidence that all of the concert venues will have a p-value between these two values. So this is a 5, sorry. So it's going to have a p-value between these two values, but our p-value for Maxima concert is, where is it? Is 0.62. So this is wait a second. Oh, no, that's the wrong one. It's this one. It's 0.1056. So you can see that 0.1056 does not fit here. So then you could say because sample proportion of Maxima concert hall is not within 95% confidence interval. It is different, or something like that. But all you have to do is point out that the sample proportion of Maxima is not within the 95% confidence interval. So some more probability. So we have a density function this time. And this now is the number of minutes after the scheduled starting time that it begins. So calculate the expected value of m. So we know that's just integration fx dx from infinity to 0 in this case. And it's 2. It's find probability that the constant now begins more than 15 minutes after scheduled starting time. So we're just finding probability that m is greater than 15, which is infinity to 15 fx dx, which in exact values, because I didn't ask for decimals, is 489. So probability that starts no more than 15 minutes after scheduled starting time. So between 0 and 15. And the 10th concert begins. Oh, sorry, I missed a whole one. So find that each of the next 9 begins no more than 15 minutes. And then the 10th one begins more than 15 minutes. So we're kind of moving into binomial here, but it's asking for a very specific scenario. So we're trying to find probability that 9 concerts are less than 15 and the 10th one is more than 15. So to do this, we would use CAS to find firstly the probability that something is between 0 and 15. So that's for these ones. And we've already figured out the probability that something's greater than 15. But if you read the first question, it says that the concert must not begin before the scheduled starting time. So that's why x is greater than 0. That's why the domain's like that. So if we already have in part fi, the probability that something's greater than 15, then the probability that something's less than 15 is just going to be 1 minus that. So it's just going to be 285 on 289 to the power of 9, because that's the first 9 concerts, on 289, because that's the last concert. So that's the 10th one, and just get your CAS to get it in decimals. So let's probably that a concert begins up to 20 minutes. So that's between 0 and 20. So given that it begins more than 15 minutes after scheduled starting time. So now we're looking for probability that something is, not something, sorry. So m is between 0 and 20, given that m is greater than 15. So if we expand this, we have to use our intersection. So between 15 and 20, and then over that it's greater than 15. And to 3 decimal places, it's 0.403. So now we have some integration. So determine the total number of square units according to this model. So you just have to integrate from 42 to 0. Make sure you consider the negatives. So 2 to 0, fx dx minus 4 to 2, fx dx. If you don't want to consider the negatives, you can just define fx. And when you're integrating, just do mod fx from 4 to 0. That might save you some time. So, but if you don't know how to use the mod function, just like do it separately. But it's pretty easy. Just put it between the lines. So determine total amount of money that the mining company offers to pay. So since it's different for each one, for this question, you actually do have to find the area of this and this, and multiply. So the area under the thing is neg's property. So multiply this area by 100,000 and multiply this area by 120,000. And you should get 880,000. So find the value of a for which px equals fx. So you can see the only difference with px and fx really is this middle thing. So this one's x minus 2, but this one's, sorry, this one's x minus 4 on this one. So if they're going to be the same, then that part has to be the same as well. So you can just equate the parts that's different. 4 on 1 plus a is 2. So then 1 plus a is 2, and then a is just 1. So solve px dash p dash x equals 0. So p dash x, if I put this into my CAS, I'm pretty sure I did, is 3x squared minus 16x plus 16 plus 3x squared minus 8x on a plus 1. So if you let p dash x equal 0, then again, I did this on my CAS. So x is 4 2a plus minus square root a squared plus a plus 1 on 3 a plus 1. This answer looked like really bad to me, so I tried to simplify it, but you can just leave it like this. So me trying to simplify was like 8a plus 4 plus minus 4a squared plus a plus 1 on 3a plus 3. And then you have to consider the plus or minus here. So in most cases, you'd get rid of one of them. But in this case, the only restrictions you have are that a is greater than 0 and x is an element of 0 to 4. So there's no real, sorry. So if you test a values in here, you'll find that for all a values greater than 0, this holds true. So x can in fact be both the plus and the minus. So it's plus minus 4 square root a squared plus 1 on 3a plus 3. So yeah, just test values to see. You can also look at the graph if you want. So if px is a transformed version of this graph, then it makes sense that there's two stationary points. So hence why you get plus or minus. So Mr. Meg does not want his property to be mined further units perpendicular to the line. So find smallest value of a. So basically it's asking for what value of a will the p minimum be less than -4. So all you have to do is find p minimum and make it equal to -4. Where a is greater than 0, and you should get your a value, which is 0.71623 decimal places. So find the a value for which total area mined is a minimum. So this is where the mod thing might not work because it might give you more answers than necessary. So you might want to do this by like separating the negative part and the positive part. So if we base the graph of px on what we know from fx, so that means we're going to have to find an x-intercept here, and it's going to be when this middle one equals 0. So when the middle one equals 0, wrong question. So we're going to do 4a, a plus 1 to 0, px dx. So this is the x-intercept. Make sure you find that. Px dx minus 4 to 4a, a plus 1, px dx. And then it's important that you don't solve this immediately because we want something in terms of a. So for now, we're just going to like get a function in terms of a by expanding this. Plus 2a plus 1. And then you can just easily find a minimum with this. You can either just use the cas function, or if you don't have that function, just do a dash x equals 1. A is greater than 0, and you should get minimum is when a equals 1. So determine the value of a that will minimize the cost. So this is kind of similar to the other question, except now we're just adding some stuff before the integral. So the cost is going to be 120,000 times, again, for a plus 1 to 0 px dx. And it's going to be 100,000 for 4 to 4a plus 4a on a plus 1 px dx. So this is the negative part. Oh, sorry, this should be a minus. Where did it go? Minus this one. Yep, and just do the same thing as before. So you want a function in terms of a. Get some pretty big numbers over here. 3a plus 1 up to the power 4. 6a 4 plus 12a 3 plus 10a plus 5. And just find the cost min, or you can let c dash a equals 0. But either way, you get the max is when a is 0.886. So question 5 is the last question. It's not too bad, this question. So find g inverse x. So just let gy equal x. So x equals 2 ln y. So y is x e to the power x on 2. E to the power x on 2, so that means g inverse x is e to the x on 2. So find the coordinates of A, where the tangent of f at A is parallel to the graph of y equals x. So if it's parallel to here, that means the gradient is 1. Gradient is 1. So you're basically just finding when f dash x equals 1. And you'll get x is 2 ln 2. And then since we need the coordinates, we're going to have to put that back into the graph of fx to get 2. So then A is going to be 2 ln 2 at 2. So show that the equation of the perpendicular line goes through the point A is this. So to do this, we're going to use our y minus 1 equals m x minus x1. And we're going to sub our point A, which is 2 ln 2, 2, and m, which is 1, negative 1, because it's perpendicular, so we take the negative reciprocal. So y minus 2 is negative 1, x minus 2 ln 2. Y is negative x plus 2 ln 2 plus 2, which is what we needed. So determine the point B. So B is when the perpendicular line that we just calculated is equal to the y, equal to the graph of gx. So just let y equal gx, and you get the x value and just sub it in to find the y value as well. So now we're trying to find the area. So the easiest way to do this would be to consider that so the area here is equal to the area here. So all you have to do is find one of the areas and equate it. But if you wanted to, you could also find the area of the whole thing. So just do so one of the options is, so I'll call this x1. That's already a. So option 1 is integration x1 to 0 fx dx plus integration a to x1 fx minus gx dx, and then integration b to a, this y minus gx dx. You could do it like that, or you could do halfway. So to do the half, you have to do integration, so twice the integration from this point again, so x1 to 0 x dx. But if you're going to do the like get half of it and then multiply it by 2, you actually have to find this point, because that's when the graph of gx is no longer like that's the end point, I guess. So that might be a bit annoying to do. So maybe this is the quickest way. So plus 2 integration, sorry, a to x1 x minus gx dx, and then sorry, this is x2. Oh, x2. Oh no. This is so x2 to x1. X2 to x1, and then the end part is you have to include y, so b to x2 y minus gx dx, and multiply everything by 2. So those are your 2 options, but yeah, I think if you do this one, you get your CAS in this form. And this would be the same as the answer, because if you expand it, so negative ln 2 squared minus 3 ln 2 plus ln 2 plus 3, so this is a 2, so negative 2 ln 2 squared minus, so this would be minus 2, so it's minus 4 plus 6, which is what the answers give you. But yeah, so either way should be fine. Just if you see like a complicated form or something that you think you can simplify, just like have a go at simplifying it. If you don't have time, just come back to it later, but yeah. So we have some generalized equations with no actual values. So they're trying to find the value of k. So the two things that we know are that at this point here, they touch, but they don't cross. So if, okay, so first thing to realize is that P and QX are actually inverse functions. So like if I take PX, for example, e to the QX, so ln y is kx, so x is 1 on x, ln y, which is what you get here. So that's one thing to realize. And then if you like use that equation, knowledge with this, the fact that they touch but don't cross. So we know that anytime the inverse functions touch or intersect or anything like that, it's going to be on y equals x. So in this case, if they touch but don't cross, that means the gradients at that point is going to be parallel to y equals x line. So the two things that we can use to find k is by equating both of the gradients to 1. So q dash x equals 1 and p dash x equals 1. So we need two simultaneous equations because we don't know the x value at which they intersect, and we also don't know k. And if you think about it, qx and px are written in terms of k and x. So that's why we need two equations. So from here we get x equals 1 on k, and from here we get x equals 1 on k ln 1 on k. So if you just equate both of them, so let 1 equal 2, 1 on k equals 1 on k ln 1 on k. So these will obviously cancel and get e equals 1 on k. So then k is 1 on 8. So find the value of k, which is greater than 0, for which the tangent of p at its y-intercept and the tangent of q at its x-intercept are parallel. So p at its y-intercept, so something like this and this, except we want these two lines to be parallel. So first we should find some dummy equations for the tangents. So tangent at the y-intercept of p is going to be y equals kx plus 1. You can find these using your CAS or do them by hand. They're not that bad because the equations are pretty good. And so 1 on kx minus 1 on y. So the next thing is that they're parallel. So if they're parallel, all we pretty much needed was actually their gradients. So just let k equal 1 on k. So k squared equals 1. K equals plus or minus 1. But since k is greater than 0, k equals 1. And that's it. So